So for my project, I decided to do the financial trading platform. My problem statement is that a financial institution needs a high frequency trading platform capable of executing trades in milliseconds with real time analytics and robust risk management. The platform must support multiple types of financial instruments and trading strategies while ensuring high availability, security, and compliance with regulatory standards. Traders require a user-friendly interface for placing trades and monitoring market data, while risk managers need tools for monitoring and mitigating risks in real time. The platform should be scalable to handle large volumes of transaction and resilient to failures, ensuring continuous operation in a highly volatile market environment. So here is my UML use case diagram. It visually represents the various actors interacting with the system and the key use cases they perform. It outlines the primary functions such as executing trades, monitoring market data, managing risks, generating reports, and providing an overview of the system's capability from the user's perspective. So for the UML domain model, I will be having 5 actors, which would be trader, market data provider, broker, risk manager, and system administrator. For the use cases, I will be using the execute trade, monitor market data, analyze real time data, manage risks, and generate reports. So, for a trader would execute trades and monitor the market data. A market data provider would supply real time market data. The broker would facilitate trade executions. The risk manager would monitor and manage risks, while the system administrator would manage system configurations and maintenance. So for the UML class diagram, I have shown here the relations between trader and trade, market data and trade, broker and trade, risk manager and trade, report also for risk manager, and system admin. So for the UML sequence diagram, in this use case for the trader, for the execute trade, the sequence involves a trader placing a trade, the system checking the market data, and the broker executing the trade, and then finally confirming the execution to the trader. So for the first step, the trader sends a trade request to trading system. Then trading system requests current market data from market data provider. Then market data provider sends current market data to trading system. Then trading system sends trade order to broker. Then broker executes the trade and sends confirmation back to trading system. And then finally, the trading system sends trade confirmation to trader. So for the one on the right, that one is manage risks. So the sequence would be the risk manager requests trade data from trading system. Then trading system sends trade data to risk manager. Then risk manager analyzes trade data and requests report generation. Then report generator generates report and sends it to the risk manager. Then finally, risk manager reviews the report and takes necessary actions. So here's the UML state diagram. So for the transitions new to validated, after the trade is created and validated, the next transition would be validated to pending execution. So which is when the trade is ready to be sent from execution. Then pending execution to executed, which would be after the trade is executed by the broker. Next would be executed to completed, which is when the trade execution is confirmed and settled. Next would be validated to rejected if the trade fails validation checks. And finally, any state to canceled, which is if the trade is canceled by the trader before execution. So here is my UML activity diagram. The process starts with the trader places a trade request. Then the trading system validates the trade. Next, the trading system requests market data from the market data provider. Next, the market data provider sends the market data to the trading system. Next, the trading system prepares the trade for execution. Next, the trading system sends the trade over to the broker. The broker executes the trade. Then the broker sends trade confirmation to the trading system. The trading system confirms the trade execution to the trader. And lastly, the risk manager monitors the trade and updates risk parameters if necessary. So here's my UML component diagram. Some of the key components would be the user interface, the trading engine, which is the core component responsible for executing trades and managing orders, the market data feed, which is responsible for retrieving and providing real-time market data, risk management system, which is responsible for monitoring and managing trading risks, the broker interface, which is the interface through which the trading system interacts with external brokers, reporting system, the component that generates reports based on trade activities and analytics, and database, which is the central storage for all trade data, user information, and system logs. So for cloud deployment, some of the key AWS services used here would be the Amazon S3, which is the object storage for storing large data sets. The Amazon API Gateway, it's managed service for creating and managing APIs, facilitating communication between the UI, trading engine, and other services. The Amazon CloudFront, which is the content delivery network for delivering the user interface with low latency to global users. The Amazon Route 53, which is the DNS service for routing end users' requests to the appropriate services. And in terms of the deployment structure, the user interface would be deployed on Amazon S3. The market data feed would be implemented using AWS Lambda functions. The reporting system is also hosted on the Amazon EC2, which is accessing data from Amazon RDS and storing reports on Amazon S3. And the system admin interface is hosted on the EC2 instances within the VPC. So here are my skeleton classes, which outline the main classes involved in the system, detailing their key attributes and methods. It also defines the structure of the corresponding databases tables required to store system data. This, all in all, ensures a foundational guide for both the application and the database, which ensures consistency and alignment between the two. So here I have trader, trade, market data, and risk management. So for grasp, the pattern chosen was controller. So the usage would be that the trading engine acts as a central controller that orchestrates the flow of data between different components like the UI, market data feed, and broker interface. So the justification for that is by centrally control in the trading engine, the system ensures that all business logic is contained within a single component. This pattern helps in maintaining a clear separation of concerns, making it easier to manage complex workflows and reducing coupling between components. So for solid, I chose single responsibility principle, SRP. So for each class, such as trader, trade, and market data, it has a single responsibility. For instance, the trade class handles trade-related operations, while the market data class manages market data. So the justification for this would be that the SRP ensures that each class has one reason to change, making the system easier to maintain and understand. It reduces the complexity of classes and makes the system more modular. So lastly, for microservices design pattern, I chose the API gateway. In terms of usage, an API gateway is used to handle requests from the user interface and route them to appropriate microservices, for example, trading, reporting, or market data. The justification for this would be that the API gateway pattern provides a single entry point for clients, simplifies client interaction with the user, and allows for centralized management of cross-cutting concerns like authentication, logging, and rate limiting. And then here is my GitHub link for the project. Thank you.